Hey everybody, this is Larry. This is day, what day is this? 21st of the Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's farm. And sometimes you see me checking out the contest page. For those of you who are new, you see there's this button on the upper left. I don't know if I don't know. Whichever way is left on your screen. You click on Unbox Surprise and you get 10 lead coins. Yay, 10 lead coins. Anyway, today's farm though is 673, number of longest increasing subsequence. Okay, so given an integer array nums, return the number of longest increasing subsequence, and it's 2000. So in theory, we can do n square. I say in theory because Leetcode is kind of sketch when it comes to n square things. Like 2000 square is a little bit slow on Leetcode. I don't know whether that's fast enough. But yeah. But let's go over the n square solution really quick. Yeah. Let's do the n squared solution and real quick. The longest increasing subsequence, of course, is without the number part, it is just longest path in a DAG, right? So that you want to get the longest path in a DAG, and then you want to count the number of them, right? So that's basically the idea. Yeah. And with that in mind, let's get started then, right? So the longest path in a DAG is basically you have a DAG to begin with, and you're trying to get the longest path, right? So let's do that part first, and then we'll add in the count later. So for right, and then for j in range to I, and you can do this, and there are a number of ways to do it. The way that I write it actually just depends on how I feel in the moment. As long as you're consistent and you're accurate with your edges and your order, then it should be okay. Yeah. And basically dp of I is equal to max of dp of I, dp of j plus 1 if num sub j is greater than num sub I, right? So that's basically it for the longest path in a DAG. And of course we have to actually create the thing. And maybe we'll rename this to like longest or something like this to be more precise, because we have 2 dp in the future. And then adding the count is actually same idea, except for now it is that if this is greater, then this is the first instance of it. Oh, I actually got this one wrong. Sorry friends, I got confused. I usually write less than. I don't know why I wrote it this way, and it kind of mixed me up. So yeah, if this is greater than, else if they're equal. If they're equal, then count sub I, we add count sub j, because now there's count sub j new paths that goes to count sub I, right? And then at the very end, and kind of to define this more specifically, long sub, right here actually, long sub I is equal to the longest increasing, strictly increasing to be clear, subsequence ending in num sub I, and count sub I is equal to the number of counts that leads to longest sub I, right? So yeah, so that's basically the idea. I think technically this starts at 1 maybe, and this also starts at 1 for having 1 element. I think that's actually the more accurate base case. And then here you maybe get the longest, right? So like max index is equal to, or oh yeah, maybe no, you don't even need the index, because there are multiple numbers that, like, you can end on multiple places to have the longest increasing subsequence, right? So maybe max is equal to max of longest, and then we can return the sum of x for x in for index x in enumerated count if longest of index is equal to mx. Maybe that's a very mouthful, but it should be okay, right? Should be, but it is not. Let me make sure that maybe I have a typo somewhere. I mean, I already had one typo that we caught, so let's kind of take a look real quick. 1, 2, 3, 3, 4. Oh, well, I made a mistake here. I think that's what happened. I kind of conflated these two things together, and that's just like a mess. That's very sloppy, actually. I'm glad that it's wrong, but basically I did two cases, right? And I kind of got lazy because I did it in the order where I added the count, but I was just lazy, right? So if the is greater than longest of I, if this is the case, then then we have this. Otherwise, that means that Otherwise, then it means that this is smaller than this. But if this is equal to the longest of I, that means that then we don't have to do the then we do the add count as well, right? Huh. Maybe my condition's a little bit off. If oh, this part's a little bit off. I think I got the I don't know why I did this. This is wrong because this is strictly increasing. I think wow, I'm just like really off today in my thought process because I don't even know what this means. Why did I do it this way? I think what I meant to do here is what I wanted to do here, but I think maybe I rushed a little bit and got a little bit crossed up. But basically, because this is not an edge, there's no reason to, like, if this is not this line of code means that we have an edge going from I to J, but this means there's no edge, so we shouldn't do anything about it. But I think what I wanted to convey was this part, but I think I got my head crossed up. I don't know. It's very hot. I don't know if you could see me, but I'm sweating like a pig or something. I don't know. Something that sweats. Do pigs sweat a lot? I think that's an idiom, but all right. We might time out, but let's give it a quick submit to see if we will. Oh well, we may also get the wrong answer apparently. Oh wow, why am I like being so sloppy today? Okay, so the longest is 5, and 5 is here, and the two paths. But what is the numbers again? The two paths, but okay, let's just print that out too. I just got lazy. Alright, so this 5 is returning 7. This 5 should should sum up these two numbers. So what did I do wrong here? Oh, I did this is equal to count of 1, but it should be this. Wow, I'm like really sloppy. Because this is now the number of paths that comes from J, or the number of paths in I is equal to the number of paths in J because you go directly. But I think I just kind of got into the resetting because I was like, oh yeah, this resets it. So of course you set it to 1, but I didn't really think it through. Am I rushing too fast? I don't know. I mean, this is one of those things where you have to go slow to go fast because as you can see, I have plenty of mistakes. It did not time out though, even though it's a little bit. Well, actually, I guess this is okay. Respect to running time. What did I do last time? Last time I actually did it pretty okay. Yeah, the last time I did everything right. Well, except for this thing, which or something like this. I don't know why this is wrong, but some other silly mistake. But today it's just a lot of silly mistakes. Maybe because I'm rushing it. I don't know. But yeah, as I say, this is n squared time and space. Oh, sorry, n squared time, O of n space, linear space, quadratic time. As you can, the space you can kind of see easily, and also the time as well. So yeah, that's all I have for this one. Let me know what you think. Let me know in your comments. Yeah, stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye bye.